Albert Einstein never accepted the concept of instantaneous causal influence at a distance, postulated by quantum mechanics. The Orsay experiment's demonstration of quantum entanglement seems to prove him wrong. This experiment confirms the postulates of quantum mechanics. But if these postulates were wrong, could Einstein have been right after all? The discovery of the corpuscular effects of light led to the rejection of the possibility that light could only be waves carried by a medium. And this medium would have to be a solid to propagate transverse waves. However, contrary to general belief, waves in fluids are essentially directional. Their effects can therefore be very localized. They have a form of duality. Additionally, there are waves with transverse property in a specific fluid. Even in water, the amplitude of waves created by a vertical plate is much greater in front and behind the plate than on the sides, over a distance proportional to the width of the plate. The amplitude of a tsunami remains maximum in its direction of propagation over hundreds of kilometers. In the air, the directional power of musical instruments has been studied in the 1960s in order to optimize the position of musicians. We now know how to produce ultra-directional sound waves. You have to position yourself in line with the speaker to hear the voice or music. The sound diffuses very slowly in the air. This weak diffusion results from the complex shape of air molecules. They gradually entrain neighboring layers of air. Let us now considering a medium composed of corpuscles much smaller than all known particles and as close to sphere as possible. Within such a medium the waves should practically not spread out. They can therefore maintain their transverse dimension over very large distances. Thus the oscillation of an electron, in such a fluid, would produce a train of waves, whose transverse surface would not exceed that of the electron. We can therefore think that such a train of waves could have effects similar to a corpuscle, by colliding and expelling an electron as in the photoelectric effect. Electrons have angular momentum. During their oscillations, they cause the formation of wave trains in the fluid. But at the same time, they transmit their angular momentum to the particles which make up the fluid. When two of these particles collide, the momentum is transmitted according to Descartes' laws. This transmission occurs by elastic deformation of the particles. The elastic deformation of the particles prevents the particles from sliding past each other due to the flattening of the contacting parts. Angular moments can only be transmitted transversely. Each wave train is therefore polarized in the orientation of the angular momentum of the emitting electrons. Wave trains propagate longitudinally, but they have a transverse property, polarization. The orientation of the polarization is directly linked to the orientation of the angular momentum of the emitting electron. The polarization angles of the two wave trains are therefore identical. They are defined from the moment of emission. If no external action modifies this angle, it remains unchanged, whatever the distance traveled by the wave trains. The two wave trains are entangled from the moment of emission. Unlike corpuscles, waves can divide into two wave trains and interfere. Such a train of waves could be dispersed by passing through a fairly narrow slit, before passing through two parallel slits. A second dispersion of each of the wave trains will form two beams which will interfere on a screen, exactly as happens in water and in air. We also obtain interference with electrons, carbon-60 molecules, and even with large organic molecules. Unlike the waves generated here in water, these electrons and molecules move at very low speeds compared to the speed of light. As a result, the waves they form as they move through the fluid precede them. They interfere and cause a distribution of these elements in the space located after the slits. Areas of high pressure push electrons, atoms, and molecules toward low pressures that remain aligned in the direction of the bands that form on the receiving device. These wave trains essentially result from electron oscillations. They have effects on electrons. But why should these wave trains be electromagnetic in nature in themselves? The ocean waves make the sound beacons scream, but nobody thought that the waves would be sonic in nature. A fluid whose particles have angular momentum provides an explanation for all the properties of light. The postulates of quantum mechanics become completely useless. The Lorentz formulas make it possible to account for Michelson's experiment. Einstein would therefore be right on all counts. However, there could be another solution that avoids taking the time for a physical reality as postulated by the Lorentz formulas. Descartes' whirlwinds cause the stars to rotate. In these vortices, Michelson's experiment would also give no results, making Lorentz's formulas useless.